Hi guys, it's John here. So for about a month I've been busy working on an update for Proximal One, which was released just a few days ago. So I thought it'd be a good thing if I just went over the new features, what I've added and how everything works. So that's what this video is going to be about. So if you don't know, Proximal One is an audio system that I've built for Unreal Engine that allows you to create procedural music. It also allows you to synchronize different audio samples so that they'll play rhythmically in time. So depending on your use case, it has a lot of functionality. So you can use it just to synchronize tracks that are already created. So it could be good for like mixing different tunes together as you wander around your world, or it could be good for actually creating some procedural melodic stuff. And a lot of the new features that I've added are sort of aiming towards making that a much better process, and more flexible, with more options and basically better sound design. So let's have a look. So let's get started. So what have we got first? So in this level I've got a drum track which is just looped over, and I've just put this audio instance in and it's got the default loop thing going on. So if we just hit play, just a little thing, if you notice it sounds slightly out, it's because the drum track in this case has got live editing enabled, but this instance hasn't. So basically, if you want everything to sound Loctite in sync, you either have to have everything with live editing enabled or everything with that disabled. So live editing would just be when you're working on it, but you want to always disable live editing when you're finished with your level, with the audio in the level, because it doesn't have to run everything in real time, all the processes. So what I wanted to show you first off is this one. We've got this new quick configuration menu. This was like one of the last things that I added. So there's only a few things in there at the moment, but I'm going to expand on this in future updates. So what this does is it will just quickly configure the settings needed for a few different things. So it's not going to overwrite every single setting. It's just going to set the ones needed for these specific things. So you've got a starting point here for procedural melodies. So when you use that one, you want to use it on a brand new instance in the level, because like I said, it's not going to overwrite all the settings, it's just going to overwrite the ones needed for this. So if I just click on that, so this works in the editor, not in play-in editor. Okay, so all you have to do is you just click on it and it sets it. So if I click play now, you should hear it's a really basic melody just going on. Okay, so it's nothing fancy, it's just a starting point. So what else have we got? We've got configure for auto switch triggers nearest instance, configure for auto switch triggers using channel numbers. Now I'm going to come back to that in a moment because we're going to talk about the new triggering options. And then we've got a couple of ones here. We've got 4-bar quantization and 8-bar quantization. So what those do is they just set up the start quantization. So that'll be the boundary, the quantization period, the frequency that an audio loop can trigger at. Okay, and it will also set up the stop quantization to match as well. So if you want all of your audio tracks to trigger at the right moments, then you want to set them all to the same amount. So 4 bars is going to trigger more frequently, but 8 bars is going to be more musically timed, in my opinion. So so that's that one out of the way. So the next thing that I want to just quickly look at is we've got a new section here for EQ. So before there was some we had the 2 main filters, and we also had a low end roll off filter that you could apply. So I really wanted to add an EQ into this, like a proper, like you'd find on a channel strip in a DAW. So it's basically what I've recreated using the bichord filters in the MetaSound graph. So before we had that high pass filter which was rolling off the low end, so I didn't see the point in keeping that with this new EQ section. So what I've done is we've replaced that with the first one here, and we've set a default value to 300 Hertz. So if you're updating to this version, you might find that the low end may sound a little bit different on some of your tracks. You might need to tweak it. But we had a blend amount for that low end roll off before, and now that has been applied to this variable here, which will sort of blend in the whole EQ. So our first one that we've got the whole selection of different filters that we can use for that, and the same with the last one here as well. We've got all of these here. So the 2 in the middle are fixed parametric EQs, and we've just got some nice defaults that we can easily apply. So let's just have a listen. So yeah, EQ is probably pretty self-explanatory, but we'll just have a quick play around with it. So to get the EQ section working, we're just going to set that to 1, and when that's set to 1, it's going to ensure that a MetaSound is loaded that has got the filters running inside the graph. So EQ's not going to be running in every MetaSound, so just a little performance thing. If you don't need to use the EQ on a specific MetaSound, it might not need to be running depending on whether the filters are needed or not. So yeah, so just gonna leave that set to high pass. You can see that we've got our range for this low end one just goes up to 800. The reason I've done that is it just makes it easier on the slider to home into the frequency that you want to roll it off at. And the other 2, the middle 2 bands, you've got the full range between 20 Hertz and 20 kilohertz. A little tip actually, if you're finding it hard to get to the frequency that you want, you can hold down Command while you're dragging it, and it'll sort of slow it down. It'll be a bit more precise. Because the thing with these sliders is they're linear, they're not logarithmic, so which would be ideal. But yeah, it'd be good if Epic could add an option to that. That would be great. But for now, if you just hold down Control, we can sort of get a bit more accuracy on that. So yeah, to use the 2 middle bands, you're going to need to adjust the gain. So boosting it you're going to boost that frequency, or pulling it down, you're going to cut that frequency. Okay. And what I often like to do as well for the top band, instead of using a low pass, I quite like using the high shelf, especially if you need a bit of like just top end boost. And the high shelf is just going to boost all the frequencies above the value that you set it to. Okay, so yeah, that's pretty self-explanatory really. But it's great to have an EQ, because when you're working with different tones and filters and things, the frequency balance can sort of go a little bit out, so it does help sort of get a better sounding mix. So one of the things that I've added is this thing called fill space creator. So your fill would be like your drum rolls and things that you'd have at the end of a phrase. So your phrase would be each section, so say like 32 bars, or 16 bars or whatever. And then at the end of that phrase, you could have like a drum roll. So what this does is, when you've got it enabled, what it will do, there's two different settings, and the first one will mute the audio at the end of the phrase, and the other setting, it will basically mute the audio during the phrase but unmute it at the end, so you can decide which way round you want it. And then we've got frequency of bars, so that would be your duration of your phrase, and by default it's set to 8. And then we've got duration in beats, so that would be how long you want the muted period at the end or unmuted period at the end to last for. So that would be, currently it's set to 2, so that would kick in like 2 beats right before the end of the phrase. So if I just disable that a sec, so if we were to just hit play, I can just show you what it does. Here we are. So if I set the frequency to something a little bit shorter, so then we don't have to wait so long, so and then just enable it, I'm gonna refresh. So you notice like every 2 bars we're getting a muted period. And if we switch it, yeah. So yeah, it's a simple little thing, but it's really useful. You can stick that on your bass line and just have like your bass line drop out at the end, and you could have a drum loop with like a fill or something playing, and you can have that so that it's just heard during that period where the bass drops out, so that sort of thing. So yeah, I guess you could have kind of done that before with the pattern sequencer. But when you're designing sounds, you're probably going to want to use this thing. So if you're working on procedural melodies, you're going to want to use the pattern sequencer for that rather than for muting audio. So yeah, that's why that's been added in there. So the next thing I think we want to look at is we've now got filter envelopes. So before we just had envelopes for affecting the gain, but now we've got the envelopes for filters as well. So when I say envelopes, we've got AD and we've got ADSR. So ADSR requires a MIDI note off, which we don't have because we're not using MIDI, but we're calculating a note off position by using a delay from the initial trigger of the note, and then that we can get another trigger. So one of the things that I found it was sort of needing was some kind of variation in that note duration, and so now we've got an option for that. So we can use a seed value. So if we tick this box here where we've got note duration ADSR, we had this setting before, but it was in the in the envelope section, and so that would be you would set that as your note duration, and that's basically the delay from the initial trigger, which creates the trigger off. So when you've got this set, it will pick out a random float between 0 and 1, and then it's gonna multiply that float value by whatever you've got set here. So you can still use this with this setting, and then you would set your reset rate for it, so that it would be how frequent you want your seed pattern to repeat. And then we've got our seed value, so that would be like the algorithm that it uses to generate the values that it's used. So it's quite a simple little thing, but it's quite effective. It creates a nice bit of variation, and it works really well with the filter envelopes, which we're going to have a look at now actually. So let's just I'll just reset that for now, and just want to have a look and see what we've got set already here. So I think we've got filter 1 is active, filter 2 is not active. So we'll have a play around with filter 1 and the envelope on filter 1 and see what we can get out of it. So let's just hit play. So I'm just going to run through these settings. So the first one, we can select the type of envelope that it's using. So we've got our AD, which is the attack and decay envelope, and then we've also got ADSR, which is attack, decay, sustain, release. And this is ADSR is the one that's going to use this note duration. Okay, so if we select that one, the next setting is our envelope depth method. So this is basically how the depth of the envelope is applied to the signal. So currently it's using static control. So the static control is what you see here in the envelope section. We've also got 3 other options here, and I'm going to come back to this later on in the video because that's a whole other thing. So for just now, I'm just going to keep that set to static. And then we've got our depth control, which is the static control. So you can move this above 0 or below 0, and the direction you move it in will sort of depend on the sort of direction of the envelope, if you like. So it will move the signal upwards, or it will move the signal downwards, the cutoff position. Okay, so if I was to bring it down, you can sort of hear it's getting sort of filtered out if I bring it all the way down, and that's because of where we've currently got our cutoff frequency set to. So you're going to have to play around with this as well as the depth control to get the effect that you're after. It also depends on the envelope settings as well, so you're just going to have to play around with it until you get what you're after. But if we increase the attack a little bit, play around with the decay. And attack curve. If you want a more squelchy sound as well, you can pull down the bandwidth a little bit. It just adds a little bit of that resonance to the signal. So I can quickly show you this as well now, the note duration. So if we were to enable that so that we're using the seed pattern, just tick that. And you can hear that it's having an effect on that envelope. And you can change the seed value to get a slightly different variation. So it's all experimenting, playing around with it until you get something you like the sound of, really. So what else have we got here? So that was for filter 1, but we've got the same settings for filter 2. And then the rest of it is just the settings to tweak the envelopes until you get down to the bottom here. So we've got this additional one now, trigger using the pattern sequencer. So I'm going to have a look at the pattern sequencer next. So what this is doing when that is ticked, with the pattern sequencer, any step value in the pattern sequencer above 0 is going to send out a trigger, and that is what we can use for that envelope as well. So we can have our envelopes synchronized to the pattern sequencer. So just wondering if I can get it to work in the other direction as well quickly, and pull it down. So looking at the pattern sequencer now, so this was in the previous version, but it's been expanded upon quite a lot. So we just had a few settings on here before, and so what the pattern sequencer would do was it would basically run through this pattern and just set different gain values for each step. So you could set the amount of steps in the pattern and the step duration down here, and then it would just cycle over that. But you would need audio going into it that was continuously playing. Now with this new option we don't need to do that. So like where you've got your audio sample settings, you don't need to be looping the audio anymore. So all you need is that one tone going into it. And so we've got our LFO, which is controlling the pitch, and it's playing the pitch using the random step LFO with the seed pattern, and that's how we generate our melody. So with this new Groovebox mode, if you've got that ticked, what it's actually going to do now is every time the value is above 0, it's actually going to re-trigger the wave player. So we can have the same tone play wherever we want. And that could be useful if you're loading in some drum samples, for example. You can have a kick drum play re-trigger wherever you wanted it to. So where we've got a 0 value now with that enabled, on the 0 value it's actually not going to mute the audio, but it's going to apply the same amount of gain to that step as the previous step, and that will work for any value between above 0 and up to 1. So for example, if you have a step set to 0.5, the gain will be set to 0.5 on that step, and on the 0 step it will be 0.5. And so if we set that one to 1 on the 0 step, the gain would be 1, and that just prevents the audio from being cut off. So we can create drum patterns in this if you wanted to. So I've actually just disabled the filters for now because it's gonna make it a little bit easier to hear what this thing does. So if I was to hit play now, we can just go through these different settings and see what everything does. So let's have a look at it. So we've got our steps in pattern, which we had before. Now you can actually set this to any value. I'll come back to that in a moment. It doesn't have to be like a 2, a 4, an 8, a 16, a 32. It can be any value you want, and that can actually create some interesting patterns. So we've got this option here, show pattern sequencer duration, and that will just do a calculation for you so you can actually determine, you see it up there, it just determined the length of the pattern in case you actually needed to know, right? And then we've got this display pattern steps on screen, so this is really useful. If we have that ticked, you can see down here it shows you which step is currently playing. So if we leave that on for now, so you can hear it's triggering the notes. It's triggering those samples, and it's playing the whole sample. And you can set the envelope to trigger from these steps as well. So you can use the gain envelope or the filter envelope to be triggered on each one of these steps too, which is super useful. So if you did want the values to be muted on each 0 value, you can set that here, so it would work in a similar way as it did before. So you can see now that when it hits a 0 value step, it's actually muting the audio. Leave that unticked for now. So we've got a couple of options here. Pause random step LFO on 0 value. So that random step LFO is playing a seed pattern. that that is changing the note value on at a frequency of the rate that which you've set for your LFO rate. So that is 1/8 at the moment. So if I just change that, so we can hear that there changing a bit faster. But with this setting, when you've got that ticked, what that's going to do is it's only going to change the note from that LFO pattern is only going to progress to the next note when it gets value above 0. So that might be quite useful. You might find a melody pattern that you like, and you might want to stretch it out and determine where you want the notes of it triggered. When you've got that set, it will still reset the pattern based on how you've got your re-trigger rate set. So we've got that for LFO 1 and 2. I'll just disable that for now. And then we've got hold pitch state from random step LFO on 0 value. So we tick that. So if you pay attention to the pitch of the note just after the notes occur, and then if I enable that, you notice that it's holding that note instead of having the LFO change the note on those 0 values, because it is just pulling numbers out of an array at a set frequency. But if we have that ticked, now it will hold the pitch value from that value. So it means we can have more sustained notes now. And we've got that for LFO 2 as well. And then we've got another option here. So if we untick that, which is bypass pitch LFO on 0 value. So we tick that. So when it's bypassed, it's not going to apply any pitch to that step. So what happens is it's going to just play the tuning of the root note. So when it's bypassed, it's going to tune it to the root note. Okay. So the next one is really powerful, actually. This one, once you've got your head around the LFOs and how the system works, with this one, LFO alternator, we can actually use this to alternate between 2 different LFO sends. So I'm going to have to activate the second LFO to demonstrate what I mean. So I think if we just trying to think what's the best way to show this. If I enable the filter again, I think actually I'm going to disable the envelope on it. And if we set LFO2, we leave that so there's no filter on LFO2. With this alternator, it's going to alternate between different sends on so steps with a value of 1 are going to use LFO1, and then steps with a value of 2 will use the sends from the send values sets. We'll use LFO2's send value. Okay, so when it's set to 1, it's going to use LFO1's send value, and when it's set to 2, it will use LFO2's send value, and it's going to basically mute the send on the other LFO. I hope that makes sense. So to demonstrate that, if we put in a value of 2, and then we need to enable it. So this will work for the filters and the pitch, and it will work with the gain as well to a limited extent. Okay, and there's a reason for that, and that's just if you were to invert the phase, it's not fully supported at the moment. So you can hear that on that, where has it gone? On that first step, we're not getting the pitch anymore, and that's because the pitch is from LFO1, and we've set that to use LFO2 on that step. But if we were to use the pitch send from LFO2, you can hear now that on that step 1, we're getting that pitch bend occur, and that's because it's using LFO2's pitch send amount, which is, so we're not using the random step on that one, we're using the sine wave. We've also got this is new too. We can actually flip the phase on the pitch. We couldn't do that before. So we've got a few more options here as well, just to sort of help workflow. So if we wanted to flip these values, convert all the values of 2 into a 1, we could just tick that box, and it's just like a toggle, so you tick it and it just flips them, it inverts them for you. And then we've got one here, we can create a randomized pattern just by ticking that. So let's say that you came up with something that you liked, but you wanted to extend it so that the same pattern would occur throughout the whole sequence. So before that would be a bit of a pain because you'd have to manually enter it all in, but if you had the first 8 steps set now, we can tick this one and it will duplicate those 8 steps to the rest of the pattern. And we've also got a swing setting. So we've also got that in the LFOs as well. So we would need to set the same amount of swing in the LFOs too. So that would just be for when you're using the random step. So we did that to LFO 1 as well. And you probably have to mess around with the other LFO to get it sounding a bit smoother. So maybe triangle or sine. Yeah, it sounds a bit wonky. But yeah, we can adjust the swing. It probably doesn't sound too great because we've got a drum track that doesn't have any swing on it. So the next new thing that we've got here, we've got this cycle method. So going back to what I was just sort of briefly touched on, is you can change the steps in the pattern. So if you wanted to create something that was maybe a bit more syncopated and a little bit less repetitive, you could change that to like a value of 6, and then it's gonna like syncopate that pattern for you. But we can still set that so that that pattern re-triggers. So we could have it re-trigger on every 4 bars, for example. So I might just enable that envelope again. And you notice we're using the trigger from the pattern sequencer in the envelope. Maybe add a little bit of resonance into it. So yeah, this doesn't sound too musical at the moment, but I'm just sort of randomly showing you things, so I'm not really art directing it very well right now. So is there anything here that I have missed? So we've got some new trigger options, but before I do that, I just want to quickly show you one cool little thing that we've added to it. So if I set that to trigger by collision box for now. So let's have a look. So our player's here, so we're going to walk forward and trigger it. So before, when the audio is triggered to stop, so and kill audio by trigger event when that's ticked, what it would do if you had a delay effect on it before, when it's triggered to stop, it would stop the meta sound, but because the delay was actually part of the meta sound, the delay would get cut off. And I can demonstrate what it does now. If I set that to stop audio immediately, so if I hit play now and then go into the collision box and come back out again, and pay attention to what happens with the delay. Actually, if I set the delay a little bit higher so we can actually hear it, and use a slightly slower delay, Let's have a listen. So I need to trigger it. So just pay attention to that delay. So it gets cut off. But now we've got this setting, prevent delay from getting cut off when metasound stops. So what this does is it will actually stop the wave player first, and then it's going to calculate the amount of time needed for that delay to play out before actually stopping the metasound. So if we try it now, you hear the delay didn't get cut off at the end. And we've also got another little thing here, use end feedback amount. So let's say we wanted the delay to last for a little bit longer when we stopped the audio, and we can do that. It's going to put quite a lot of feedback on it, so just to demonstrate it. So if we do it again, and now just pay attention to the length of that delay as it stops. Okay, so you get the idea. So, moving on. So we've got a couple of new triggering options. So before we had the trigger system, we could use these exit triggers, and what the exit trigger is basically when an audio is triggered to stop, it would send out a signal to another instance to trigger that. So you could have like continuous audio. But to do that would require entering in channel numbers. Now you can still do this if that's how you've got it set up on your projects already. If anyone's using this, we can still do that. We haven't broken anything, but we've also got some new options here. So now we can set it to trigger the nearest instance to the player as the player leaves the collision box. So I think I'm gonna have to put in some different sounds here, so just bear with me a moment. So if I come to blueprints, let's drop that one in. So that'll be playing the default sound. And I'm going to use the quick config here to set it up for auto triggers. So you just select it from the menu, and if we do that one as well, just trying to think. Actually, I want to disable auto switch for now on these, so I'm going to come back to that in a moment. So we're looking at nearest instance triggering at the moment. So we've got our trigger method set to collision box and exit trigger only, and send exit trigger ticked, and exit trigger method nearest instance only. And we've got receive nearest instance trigger ticked, so that means we can receive the trigger. Okay, and we've also got this one, disable collision box trigger after the first exit trigger. So to start a chain of events, we're going to need the player to activate the audio through a collision box. But then if the player then triggers the next instance, we're not gonna want that collision box to re-trigger the sound unless you do want two instances playing together, but we can use that to disable the first we can use it to disable the collision box triggers once we've got the exit trigger sequence running. And the cool thing about this is you can have an instance in your chain that doesn't send out an exit trigger. So let's say if you had a sequence of instances and you got to the last one and you didn't want that one to trigger another instance, so you could have that one unticked on that, and what would happen is it would automatically reactivate the collision boxes at that point. So it's doing an evaluation constantly to see how many instances that are using receive nearest instance trigger, exit trigger. It's doing an evaluation to see how many are actually playing. And if it finds out that if it sees that there's none playing, then it will reactivate the collision boxes. So I want to demonstrate how this actually works. So we've got that one. That's our default sound, and we've got that one that we were messing about with before. So if I was to put another one over here, and let's change the audio on that one to let's find a different loop. So that one will do for now. So just gonna change that, and hopefully I've got this set up correctly. So I'm gonna go into this collision box, which is gonna trigger this instance to play. When I come out of the collision box, it is going to trigger the nearest instance to it. So if I come out on this side, it should trigger that one. If I come out on this side, it should trigger that one. Also, there's one other thing that I want to do, is I just want to make sure that that I've got these set up so that they're quantized the same as well. So let's just give it a go and see what happens. So if we go into this one, let's trigger this one. And if we come out on this side, it should trigger the one to the left. And then as we come out of that one, it'll trigger that one in the middle. If we come out on this side, so we've triggered this one. And so it's basically wherever the player is when it stops the audio, when it sends the stop signal, it's gonna decide which is the nearest instance to it and then trigger that instance. Okay. So this is good, but we do have an issue here which we might not want. For example, currently you have to enter the collision box and then come out of it in order to send out the next stop trigger. Might be okay if your player can only pass through the collision boxes to progress through the level. So if you've placed your collision boxes where the player has to move through them, that's fine. But in the example where the player may not actually pass through a playing collision box, the player might actually wander around the collision box, and then the audio doesn't progress any further because it can't get a stop signal for that instance. So with that in mind, we've got some new a new feature called auto switch. And so basically what that does is, if an instance has been triggered by the exit trigger system, it will check if the instance that's currently playing is playing with the player outside of the collision box, and it will there's an evaluation time that you can set. So let's say like after a couple of beats, for example, you wanted to say, right, the player's been outside for this amount of time now of the playing instance, let's automatically switch the instance to trigger the next nearest instance. So if we look at the trigger settings, right down at the bottom we've got auto switch if player is outside collision box, so we can enable that. And so I want to enable it on all of them. So let's have a listen, see what happens now. So it's triggered that instance, but let's say this time we don't go into the collision box and we run around here. It's triggered the one in the middle because that's what we were closest to, and that's triggered this one. So yeah, we've got this auto trigger system now. So you can have your, it can be quite easy, quick to set up audio that's constantly triggering and progressing. So if you did want to change the evaluation period that uses before it enables it to switch, in the clock blueprint we've got this, where is it? Auto switch, amount of beats to wait before switching. So that's not the amount of beats that it will switch on, it's sort of the amount of beats that it will wait before it starts to evaluate which one needs to be switched. So yeah, I've got some additional things planned that I want to add to this triggering system. So one of them is when an instance triggers to play, we're gonna have it set up so that we can have other instances paired to it. So I've already started working on it. So basically what would happen is when an instance plays, it sends out a start signal to the instance that is the slave to it, and it'll adopt its collision box transform as well. So I've got that working at the moment. I haven't done the stopping part of it, so yeah, I'm working on that at the moment. So that'll be probably in the next update. And another thing as well with the nearest instance triggering, currently it's going to trigger any instance that's close to the player. But let's just say that you had a wall between two different instances. Maybe you've got different rooms and corridors and things, and you wouldn't want the audio on the other side of the wall to be triggered, for example. So that's also in the works. We're going to have it so that there's an option to only trigger based in line of sight. So if the instance is occluded, for example, by a wall, then it won't be triggered. So yeah, that is another thing that is in the works, and it will be out in the next update. So this is quite a complex trigger system, so you might need a little bit of refining here and there. So if you have any issues with it, then just let me know, and I'll see if I can address them. So before we had our custom meta sound proximity. So this has been changed now to custom proximity. So this is a proximity variable for this collision box, and we can see that we're adjusting the visualizer with it. Now this can still be used with custom built meta sounds if you're using that feature, but now we can actually assign different variables to this custom proximity variable. So for an example, with the let's do audio sends. So I mean, there's only at the moment there's only a few different ones that you can assign to this, but I'm looking at other ones that I can add to it as well. Not trying to clutter the system too much, but these are really cool. For example, if we were to say we wanted our large reverb to be affected by the player's proximity, we could set that to one of these three values. So use custom proximity value range 1. So in our custom proximity section, we've got 3 different ranges, and we've currently set that to range 1. So what that would be is you'd set that here for the custom proximity to control the send value for that reverb, and then you would set your minimum value. So if we wanted our reverb send level to 1 on the outside of that collision box, which is where our minimum is currently, and then we want no reverb in the middle, we would set it to 0. And it's now we can also type it in here so that we know what it is. If we were to come into that collision box now, you'd notice that we have a lot of reverb on the edge when the player's on the edge. So let's just do that. Just wait a moment for it to start. Oh. Probably a little bit too much reverb, but and then yeah, you notice there's like hardly any reverb now. And so we've got that. We've got a few different ones that we can assign to a custom proximity variable. So we've got what else have we got? We got the filter depth. We can do that, and we can do that for filter 1 and 2. That's on the envelope. Um, so basically, any parameter that just sounded good when I was adjusting it, I thought, yeah, that would be a good addition for that variable. So there's a few different ones just scattered around. So another example is in the LFO, we can use the pitch send. We can send that as well to that custom proximity. Also, you can do it for the wave player. So the transpose on the wave player, that can be applied to it. So if you wanted the pitch of the sound to change as you move through the collision box, you can do that as well. And we've also got LFO rate method. Now this one is a little bit more interesting because we've got 6 options here. So we've got without dotted notes and with dotted notes. So if I just where has that gone? If I just hover over that, you can see what's going on here. So when the LFO is synced, so this will work when it's synced and not synced. So when it is synced, as the player moves through the collision box, the LFO rate will move up in increments, and you can see the value that you would need to enter into that custom proximity range to get that specific rate. Okay, so you can see that we've got 2 columns there. We've got our rate, and then we've got our rate with dotted notes. And so you can set your range and select the rates that you want within that range. So when the LFO isn't synced, it will just it will run free like this with the LFO rate when free. It's kind of similar to that. So you would set your values to sort of act the same as the way this thing does. So what else? Where's it gone? Let's type it in. Custom proximity. So just another thing. So I'm not going to go over all of these settings because they're I've got videos about that already. So but we have got this additional option, which is clamp range at collision box boundary. So before, the range would be clamped off. So what that means is when the player goes outside of the collision boxes, the values stop changing. But you can untick that now, so that, let's just say we had we set a custom proximity range to control the transpose. So what would happen before, let's say we entered at one end and we had it we had our custom let's just say we had sorry, just bear with me a moment. We had edge to edge fading, okay, like that. So if our player came in this side and this is controlling the transpose, it would start at its lowest pitch value, which is whatever you set it to within the range, and then the player gets here and it would get to its highest pitch value, and then the player leaves, it's going to stay at that value. So with that unclamped, what would happen now is the player could leave the collision box and the pitch would continue to rise as the player moves away from the collision box. So that's quite useful. So the last thing that I just want to look at is I realised that the system didn't actually have a proper pause function. So that has now been added, and there's a few options in the clock blueprint that we can use to decide how we want to set that up. So you can either use the input action, which is already set up, or you can use an event dispatcher. So the input action that's currently set up will pause it when you hit the key P on the keyboard. But if you didn't want to use that key, you can, if you go to the content drawer, and then in the Proximal One folder, if you look for input action, we've got this IMC asset here. If you double click on that, we can actually change our input for pausing it here. Okay, but if you don't want to use that, you can just use the event dispatcher if you want to set it up in your own blueprint. So that's super easy to do, and I'll just quickly show you how to do it. So if I come up to here, I'm just going to create a blueprint class, and just call it pause. So go into the event graph. So you can run this on you don't need to run it on a timer or event tick or anything. So you just place this in your logic somewhere. So you would want the get actor of class node, not get all actors of class. It's get actor of class in this case. And you want to search for proximal, and then you want the audio clock one, not the other one, the audio clock. Okay, and now if we drag off of that and just type call pause, and you can see it's come up here, and it's as easy as that, really. So it's a toggle. So when you call this event dispatcher, it's going to pause, and when you call it again, it's going to unpause. Okay, so that's pretty much it. It's fairly simple. So I'll just quickly show you what it actually does when I hit play. So if I just hit P, you'll see that we get this message come up, and that's just a print string. So that can easily be disabled if you don't want to see that. But if I hit P again, it'll toggle it. And you notice that when it's restarting, it actually restarts at the beginning of the bar. Now, there's a reason that it does that, and you can change that if you want. But the reason is because Quartz runs on the audio thread, and the meta sounds will pause on the game thread. If you don't get Quartz to re-trigger the audio, and you're pausing the two things sort of individually, you can get a drift where they start to go out of sync, and that's just the way that this system works. It's just the way that Unreal is with Quartz. Meta sounds aren't continuously synchronized to Quartz. They're just triggered by Quartz at the start. Okay, so that's why you would get a drift. But I can show you. We can change that here. Refresh audio when unpaused. So if I just untick that and have a listen and see what happens. I mean, at the moment it's not too bad. It sounds quite well synchronized. The problem occurs is when you've got a lot of instances running in your level. Then when you hit pause, because it has to like it has to pause every instance. It can start to drift a little bit, and you might notice that it starts to sound a little bit unsynced, which isn't great. So we can fix that just by having that enabled. So again, I'll just show you. Okay, so that's kind of running like the global refresh event inside the blueprint when it's paused. So what happens is any instance that's currently playing will be re-triggered when you unpause. Okay, so it's not gonna restart everything, it's just gonna re-trigger the ones that were playing when you hit pause. And yeah, we've got this option here, show print string, so you can disable the message on the screen if you don't want to see it. So but if you did leave that enabled, it wouldn't affect a packaged build, because it's a print string, and that's just a development thing only. So there is one other thing as well. So in the audio instance, we can search for pause. We've got a setting here as well, can be paused. So if we were to untick that and then hit pause, you notice it didn't pause this part, it didn't stop that part. And that could be quite useful, because that means that if you wanted some different music to occur when you hit pause, you could set up an instance somewhere in the level and have that not be affected by the pause, and you could trigger that instance using an event dispatcher. So yeah, there's a little bit of flexibility in there. So I think that about covers it. Yeah, so if you made it this far through the video, thanks for watching. I know it's been a long one, and thanks to everyone that's purchased this so far. It's been really helpful, because my financial situation's not great at the moment, so any support like that is just absolutely wonderful for me at the moment. It really makes a difference, and it enables me to carry on working on this system and improving it. So yeah, major thank you to the people out there, you know you are. So yeah, thanks for watching. Hope you found this interesting. I know I didn't really create much great music in this video, but it might have given you some ideas. So yeah, hopefully this system's gonna keep progressing and just keep getting better. So it's shaping up to be something pretty awesome, and the sound design capabilities of it are really good. I'm actually considering recording some of it into a DAW and actually making some music to release that was actually procedurally generated, like melodies and stuff, because it's really good at that kind of thing now. So yeah, thanks for watching. See you with the next video. Cheers. Bye.